Hello, I'm Sibi, studying third year mechanical engineering in Coimbatore Institute of Technology. I'm here to present a seminar on planing machine and I'm going to explain the working principle of a planing machine, parts of a planing machine, tools used and its applications. Introduction. Planing machines, which are also called as planers, are similar to shaping machines, but these are larger in size and larger workpieces can be machined using this. Planing machines are generally used to generate flat surfaces. Besides these, cross-sections like grooves and notches can also be produced. Working principle. A table on which the workpiece is placed is mounted on a large bed, and the workpiece will remain fixed to the table and there won't be any relative motion of the workpiece. The table on which workpiece is clamped is imparted a reciprocating movement, that is, to and fro motion. During the forward stroke of the table, cutting takes place. Chipping of tool cutting edges can happen during the return stroke because the tools rub along a workpiece while returning. In order to prevent them, tools are either tilted or lifted during the return stroke. These to and fro motions of table are achieved with the help of electric motors, and the power transmission takes place either by mechanical or hydraulic means. Parts of a planer. The major parts of a typical planing machine are bed, table, column, cross rail, and tool head. Bed, which is larger in size, is the part which supports the whole machine. Table, which is mounted over the bed, is where the workpiece is attached. Columns of a planing machine are mounted vertically where the tool heads are mounted. Cross rail is supported by the columns and are mounted horizontally. The tool head is placed where the tools are mounted. Let us see in detail about the parts of the planer. Bed. The bed is the heavier and larger part of the planing machine and is usually made of cast iron. And this part is too heavy since it has to support the whole machine. Leveling jacks or pads are included on the bottom of the bed to provide a means of leveling during installation. The length of the bed is little more than twice the length of table since it has to provide space for the table's reciprocating motion. Beds have guideways over its entire length and houses driving mechanism in it. Table. The table is the platform where the work will be set up for machining. The table supports and reciprocates the heavy work pieces during the cutting action. The table moves back and forth on the bed, carrying the work past the stationary tool. T-slots are provided on the entire length of the table for securely fastening the workpieces to the table. In addition to the T-slots, a row of holes are provided on the table to accept stop pins that prevent the movement of the work under the heavy cuts to the common planer. Column. On either side of the bed, two heavily ribbed columns are located. Two tool heads can be mounted, one on each of these columns. Within the columns are the various mechanisms that transmit power to the upper parts of the machine from the main drive motor. Cross rails. A cross rail is connected to the two columns to help in accommodating a third tool head. If necessary, an additional tool head can be mounted on the cross rail. The rail can be clamped at any position on the column by means of hand or power clamps. The tool heads can be fed manually or more gently by automatic feeding arrangement with the power coming from the motor and the feed gearbox that is housed within the table. Tool head. The tool head can be moved along the cross rail for the feeding action while the depth of cut can be controlled by moving the tool downwards. The tool head can be tilted for any given angle cut on the workpiece. The tool heads will be provided with counterweights for force equalization and smooth movement. It is possible to mount more than one tool head on the cross rail as well as the columns on both sides so that multiple surfaces can be completed simultaneously. This helps in reducing the total machining time since planing is relatively a slow operation like shaping. The workpiece during the machining operation will have to remain fixed to the table. Since heavy cut care made in planing, the cutting forces are also large and the workpiece should not be shifted due to these forces. Most of the time, complex workpieces will be machined, so the setting up process requires heavy duty T-bolts and clamps. Tools. The two cutting tools used in planers is in general are single point cutting tools similar to those used in shapers. However, in view of the heavy cuts taken, these normally have large cross section and are more rigid. If the entire tool is made from high speed steel, it becomes more expensive. So, tool holders are made from less expensive heat treated steel and the tool bits are used for actual cutting or made from high-speed steel. Cemented carbide can also be used with the planers to get higher material removal rate. The tool geometries are similar to that of shaper, and similar to shapers, planers also can be mechanically or hydraulically driven. Types of planing machines. Planers can also be classified as single column planers and double column planers. The single column planers, also known as open set planers, has single column supporting the cross rail on which a tool head is mounted. Another tool head can also be mounted and fed along the vertical column. The configuration of the open set planer permits very wide work parts to be machined. A double column planer has two columns, one on either side of the base and work table. The column supports the crossrail on which one or more tool heads are mounted. The two columns provide a rigid structure for the operation. However, the two columns limit the width of the work that can be handled on this machine. Applications. Using planing machines, logs, castings, bases and tables for different types of machine tools, lathe beds, forger hamming die blocks, large fixtures and molds, rolling mill parts, and parts for large hydraulic presses can be machined. As mentioned earlier, planers can be used for machining flat surfaces either in horizontal or vertical planes, curved surfaces, any inclined plane, and several other shapes which include V-groove, square grooves, T-slot, dovetail slot, and gear teeth. I have listed here the reference books I used for my preparation for your future use, so make a note of those. Thank you.